Hola, buenas tardes, ¿cómo están? Lo vamos a hacer muy rápido y breve porque creo que es lo único que nos está deteniendo para la comida, ¿no? Pero eh, como pudieron ver en otras presentaciones, Big Data es una parte fundamental de las nuevas organizaciones, ¿no? Muchas de decisiones de negocio y muchos de los procesos de negocio ahora están dependiendo mucho de este Big Data. Ahora, hay un reto muy importante, muy interesante, ya que muchas de las plataformas de Big Data están basados en open source, ¿no? Y la parte de open source conlleva muchos potenciales riesgos, ¿no? Entonces estamos dejando muchas decisiones de negocio, ¿no? Que potencialmente puedan tener decisiones y grandes impactos de negocio a través de nuestras plataformas de Big Data, ¿no? Pero con posibles fuentes de fallas, ¿no? Entonces la plática de hoy que va a dar Mitun va a ser muy enfocado hacia los potenciales riesgos de utilizar plataformas Big Data que están basados en open source, ¿no? Porque open source conlleva muchas vulnerabilidades, ¿no? Y gracias, los dejo en buenas manos con Mitun.
Hi, everyone. Apologies, my Spanish is just as bad as my English, so I'll talk very slowly. But today, I think, obviously, Alejandro has already given you an introduction of what I'm going to be talking about, so let me just get started. So I like this little image because actually every day when we get into our cars and every day developers develop software, they don't decide that they're going to reinvent the wheel and they're going to use a new type of wheel. You know, suddenly they decide that they want to use a triangular wheel versus a circle wheel. Every developer uses open source software. There is no developer in the world anymore that builds software from scratch. And this applies also for data analytics platforms, things that you use your data for. Okay, so if it works, why reinvent it? So we know everyone uses open source, and that's great. And you get a lot of acceleration and obviously a lot of new features out the door by using open source. But there are some considerations you need to take. Okay, so for the first one, all open source components are not developed equally. There are billions of packages that are pushed to the open source community. And it's not only Java, it's not only C, it's everything from Ruby, Python, JavaScript, new languages like Go. Okay? These are all open source packages that developers are using to develop your data analytics platforms. 85% of all applications, whether they are these data analytic platforms or general applications like web servers or sites or retail pages or banking applications, whatever they may be, 85% of them are actually open source components that are being used. So what does that mean in terms of the effect? Last year alone, there were 500 billion download requests for different types of components that are being used by developers. You'll see I've highlighted Java and PyPy. Why? Java is one of the biggest used languages for data platforms, big data. Python is used by lots of organizations and enterprises that want to consume or sift through this big data that they have. So how do you control those dependencies that developers are bringing into your organization? How do you control the security of your data? Another aspect is languages, packages, software that's being used to develop these applications, these enterprise-grade applications. There's a lot of complexity behind that. It is not only about the dependencies that you are bringing in as a developer, but it's also about the transitive dependencies. So the child of the child of the child. How do you control that? You don't know whether a developer sitting on Gran Via who has no intention but just wants to push something out to the repositories out of good intention is different to someone sitting in Plaza Mayor going, well, I want to do a bit of crypto mining, right? How do you know the difference? You don't. It's very difficult. And there are 300,000 components downloaded, or more than 300,000 components downloaded annually. So why is having an open source security policy important? Well, the first thing is is 1 in 10 open source components used as part of your big data, retail applications, banking applications, telephony applications, whatever it is you're developing, 1 in 10 of those components have a known software vulnerability. But what does that mean? That also means that there is also 9 out of 10 of them that potentially you do not know whether they have a software vulnerability or not. Why is that? Because some of these ecosystems typically do not publicly disclose whether there was a breach or whether there is a problem with that component. Let's take the Java ecosystem just as an example. 170,000 components downloaded annually. There were 3,500 unique components. But what does that mean? That basically means out of 11.1% of them, we know that there are vulnerabilities with those components, right? But these were downloaded 170,000 times. They are potentially in applications that you are using today. Now that doesn't seem like a large number, right? But the problem comes when, where are these components coming from? How are they even making it into your organization to build these big solutions, right? Well, the problem is most developers don't have a build system, right? Or some sort of policy governing how they are actually bringing in these artifacts. So you'll see here that actually a small percentage of these are using a repository manager. These downloads over here are going directly to your developer's desktop. They are going directly into your application without any visibility at all. So 90% of those downloads, especially from the Maven Central, did not come from a repository manager. So there's no governance, there's no control around what your developers are using for these enterprise-grade applications. Let's look at something that has become a lot more popular in the past year, 2 years. JavaScript, NPM. 60,000 plus downloads per year per developer. And of those, 51% of them have a vulnerability. Now imagine the scale of your risk footprint. That is huge. You have 100 developers, 100 times 60,000. Every single one is bringing some risk into your organization. And that's exposing you to problems because you just do not know what these known vulnerabilities are if you do not have a security policy in place. So, is this getting better or is this getting worse? Well, actually, this is getting worse over time. So from about 2014 to 2019, 71% increase in verified suspected breaches. So this problem is not going away. The fact that this is happening every day and languages are becoming more popular, and Python and Ruby and all of these different languages that are being used, R, for example, this problem is just going to get worse. Your threat footprint is getting bigger. 1 in 4 organizations have at least one open source breach in the last 12 months. Here's an interesting fact. In a panel that I was listening to earlier today, there are 13,500 breaches in Spain alone. Of those, there are 400 severe to critical breaches. Of those, there were 15 extremely severe critical sources. Now, where did this come from? This came from the body that looks at the cybersecurity policies and rules within the country of Spain. So these are things that you may not know, and you're probably hearing for the first time. And here's the best part about it, or the worst part about it. 38% of organizations do not have a security policy in place, or that security policy does not cover the developers in the data analytics or the big data space. So what do people or what do organizations know, or what do enterprises know about security? And you'll have a security organization, and I'm sure you will. You'll all have a security team, you'll have a development team, you'll have a big data team. What do you know? Everyone understands this space, right? Network attacks. Everyone has perimeter detection, right? Intrusion detection, WAFs in place, right? That gives you a sense of security, right? Maybe a false one, but it does give you a sense of security. My code, static code analyzers, tools that are used to govern and look at rules and policies of things where you are building and developing yourself, right? But remember the fact that I just told you only about 4 slides ago. 85% of your code is coming from open source. That does not scan for that. Now we start to move along the timeline with the understanding path. The OWASP top 10. Everyone has probably heard of this if they've heard of some sort of security. And in the OWASP top 10, there's the A9 rule. And it's about using components with known vulnerabilities. You have to try and avoid this. But the problem is, most organizations and enterprises struggle to keep up with attacks that happen at the ecosystem level. You have no control over what happens in the NPM world, the Java world, right? The PyPy world. These are just developers seemingly being helpful. So let's take a look at some examples, right? Let's see what's happened over the time. Commons Collection, 2015. JBoss was made vulnerable, okay? There were 23 million downloads of this particular package. Of that particular package, 78% of them were vulnerable. There were actually 25 group artifact versions, so these packages that are used in there. And of them, 7 of them were actually vulnerable. And to this day, those are still being downloaded. And organizations just simply do not know that there's a vulnerability. Everyone's obviously heard about this, right? The flagship of security breaches in the world, right? Equifax. What's it about? Well, there's actually a Java package called struts2 core. It was made publicly available to the entire community that it was vulnerable. And their advisory was upgrade to a new version. But guess what? As an ops team, they don't understand where this is being used in your applications or your data solutions. So obviously, some organizations did. The NSA obviously could see some exploits being happening against their perimeter detection. But then, March 10th, 2017, there was a breach. Everyone in the world heard about Equifax. And now everyone stood up and realized the importance of security. But they weren't the only people. Indian Post, Monero crypto mining, and still today, 65% of all the Fortune 100 companies still download this vulnerable version. Apache Spark. It is a data analytics platform, right? Open sourced by the Apache Foundation. There was an exploit in 2018, so not long ago. Guess what? This is to do with a configuration activity. Simply allowing a REST API. Now, how do the administrators know how to configure this, right, for one of their standalone clusters? They don't realize that a REST API endpoint is open. But guess what? That was vulnerable. And you could actually execute anything you wanted, unauthenticated, against your data analytics platform. How does that affect you? All of your data sources. Every single one of them, if you are using some sort of Apache Spark framework. Hey, but that's only the data sources, right? That's not a problem. Actually, what other applications use Apache Spark? That is the open source ecosystem around Apache Spark, right? The things that are touched by it, the things that it potentially interacts with. Apache Storm, right? Real-time computational, right? Fairly new to the market. Great open source tool. Lots of people are using them, right? But guess what? You can actually just write a file to it and pass it in, which could potentially then open up a door. And yes, again, fairly recent. Python. Why did I bring this up? It's one of the biggest data languages that people are using. Typo squatting. What is that? It is the use of a package name that is similar to another package that is designed to do exactly what it's designed to do. Typo squatting just simply changes the name of the package so developers don't realize. Why do I mention this? Python developers are fairly new. That market is fairly immature, right? So security may not be something that they take seriously at this moment in time, or they don't feel that they're affected by it. R, another language. This is by a website called Redis.is, openly admitting that actually some of these packages, especially if they come from GitHub, are simply not qualified for any vulnerabilities or open source security vulnerabilities. There is only an aspect of R, which uses R Java, that can be scanned to see if there is anything there. But frankly, only a few of the people in the R development community actually check for vulnerabilities. And this is a new up-and-coming language as well. So what does that mean? Well, if you're one of these companies downloading these vulnerable components, and this is Struts2, this is an example, but if you download them and you are still downloading them, then you potentially have some footprint of risk within your organization. That may potentially mean that you're either the next Equifax of Spain, right? So what do you need to do? You need to automate faster. You need to build and validate and qualify these changes faster. Back in 2006, a breach may have taken 45 days to expose. Equifax took 3. Within 3 days, it cost the company around $260 million, and all of the senior executives within the top level took early retirement. Economics of cybercrime. Yes, we know it costs a lot of money to fix, but why are people doing it? Financial gain? Other? These days, this is actually a more profitable business than the drug trade. People are making more money out of vulnerabilities than actually things like the drug trade. So what's actually happening? And this is obviously a 2009 report by Verizon, but what do they see happening? They're obviously seeing organized crime, so crypto mining, things like that, coming down slowly. State-affiliated attacks, data. What do they do with that data? Everyone heard about the Trump and the US elections, right? System admins. Why is that going up? Because people just don't realize that they need to configure something, change something inside of their code, inside of that open source component. And so system admins are now becoming the front line of security for your organizations, right? But what do they know about security? How much education have they had around security? Hackers are getting more and more intelligent. They're using blinds, essentially, to mine data. So they may use ransomware to actually hide a breach. And effectively, it's a very clean way of removing all of their footprints inside of your breach. So ransomware is another way of doing that. But what's really important about this, and what am I trying to say here, is the supply chain. This isn't just about big data. This isn't just about the solutions that use Apache Storm or Apache Spark. This is about the supply chain. Security around big data starts at where you are developing applications. That is where you should start to secure your organization. This is a really interesting timeline about how supply chain attacks in your software development or your secure development lifecycle is getting worse. It's not getting any better. And you'll see from July 2007, right, there have been numerous attacks on the actual software supply chain. Things that are out of your control. This is the open source community. This is your developers who embrace open source and are using all of the different types of wheels from public data sources. Let's look at a few examples. July 2017, someone accidentally put their credentials online in a GitHub repository. Typo squatting. NPM package was slightly renamed. Credentials were changed. Someone had access to push a commit into the main repository of this particular component. The same thing for Python. which is obviously a big data analytics platform that's being used at the moment. Changelog problems, things where you can just take and post details from things as simple as a changelog. NPM. So these are all supply chain attacks. These are all attacks on where your developers are getting open source components to develop their applications. Python module decorator. Here, right plain in sight, you can see the post to a site that allows the credentials to be stolen. This was a great example, ESLint. Package had been developed, someone had changed obviously the format of, or someone was actually trying to contribute to ESLint, but it was hijacked. It was hijacked by an unknown party that changed the credentials, pushed in a commit into the open source community, and everyone started to use the new version of ESLint, which was vulnerable. So, what are the important takeaways? You need to look at automation and improve automation and security policies around your automation aspects. Okay? When Etsy turned around and said they are doing 10 deploys per day on their website, everyone has been trying to catch up with that since. So everyone is trying to automate faster and look at this. But in doing that, security and the impact of that on your data, on your applications, is being forgotten. So some of the takeaways. Big data, they're still maturing. These are things that are still not mature enough, and security is still not being taken seriously. Increased OSS usage. It's going to happen. People will continue to use open source components. No one wants to reinvent the wheel. But what are the things that are less understood? Better controls, policies that are in place. Secure your supply chain. Make sure your developers are downloading from a known source. Make sure that you know where these packages are coming from. Understand what's being used. Do a software bill of materials. Understand which packages are being used. Understand that 85% of whatever you're using is open source, right? It is a fact. Do software composition analysis. Static code analysis only does not work. It only looks at 15% of your application, not 85%. Thank you.